Hey guys, welcome to the channel. In one of our previous videos, we discussed about modulation. Today, we'll be learning about amplitude and frequency demodulation. Let's say you receive a package from a courier. Now, what is valuable to you is what is present inside the package. The outer covering is just a means of protection. Without the covering, the items could have been scattered or lost. You could have also received them in a damaged condition. Similarly, we have learned that the information from the sender is modulated with the help of carrier signals and transmitted to the receiver. This modulated signal carries the information that needs to be separated from the carrier signals. This is done by the process of demodulation. Demodulation is defined as the process of extracting the original information or message from the carrier wave. The circuit that is used to perform this action is termed as a demodulator. In today's video, we'll be discussing amplitude demodulation and frequency demodulation. Amplitude demodulation can be done by using two ways: by using a square law detector circuit or an envelope detector circuit. The block diagram of a square law detector consists of a square law device and a combination of resistor and capacitor circuit which form the low pass filter. The AM wave is sent through the square law device, the output of which is the square of the input voltage. This signal is now passed through the low pass filter. The low pass filter eliminates components from the received signal and we obtain the original message signal alone. Next, we have the envelope detector circuit. The envelope detector consists of a diode and a low pass filter circuit. The diode, as we know, conducts current only when forward biased. When we pass the alternating modulated wave through the diode, only the positive half passes through it. This positive half charges the capacitor. During the negative half, the diode is reverse biased and the diode does not conduct. During this period, the capacitor discharges, the signal flows through the resistor and we get the original message signal. Well, that's all for amplitude demodulators. Next, we look into frequency demodulation techniques. Frequency demodulation is used to recover frequency modulated waves. The different types of frequency demodulators that are commonly used are slope detectors, ratio detectors, Foster-Seeley detectors, phase-locked detectors, and quadrate detectors. First, let's discuss about the slope detector. The slope detector circuit is the simplest form of the FM demodulators. It first converts the FM signal into AM signals using an LC circuit, as we can see in the given image. The LC circuit is a combination of an inductor and a capacitor, which is used for storing charges. From here, it extracts the information by tracing the envelope of the input signal with the help of an envelope detector circuit. The original message signal is received as the output here. Next, we have the ratio detector. This detector uses a double-tuned transformer to convert instantaneous frequency variation to amplitude variation. The transformer S3, as shown in the image, provides a voltage step down, avoiding the damping of the incoming signals. Diode D2 is connected in reverse direction in respect to D1. These two allow only certain voltages to pass through them and work alternatively. Their voltages are taken across the capacitors C1 and C2. Capacitor C4 takes the average of the sum of the two voltages and makes sure that the output voltage does not exceed a certain limit. The final output is taken across points A and B as the original message signal. Next, we have the Foster-Seeley detector. The circuit of Foster-Seeley detector is quite similar to the ratio detector. The only difference here is that instead of a third transformer, an RF choke is used. The RF choke is an inductor which blocks all high radio frequency signals. The Foster-Seeley provides a higher output and lower distortion when compared to a ratio detector. Depending on the input frequency, the balance between the two halves of the transformer changes. The result is a voltage proportional to the frequency deviation. The choke ensures that no high frequency signal is produced at the output. Here, the capacitors are the ones providing a filtering action to the signal. The next type of FM demodulator is the phase-locked loop detectors, or commonly known as PLL. It consists of a phase comparator, a low-pass filter, and a voltage-controlled oscillator. They are used in many electronic devices because of their low cost. The phase comparator produces two frequencies, which are the sum and difference of the input and output frequencies. These frequencies are then passed to the low-pass filter, which only allows DC components to pass through it and also amplifies the signal. The voltage controlled oscillator, or VCO, produces certain frequencies when no voltage is applied to it. This frequency can be shifted by the input of the LPF. Depending upon the input from the LPF, the frequency can be shifted to either side. This process continues until the frequency in VCO is equal to the frequency in the phase comparator. The final output, which is the message signal, is taken from the VCO. Finally, we have the quadrature detectors. The circuit diagram of quadrature detectors looks like this. In quadrature detectors, the signal is split into two. One half of the signal directly enters the mixer, while the other half is phase shifted by 90 degrees. This phase shifting is done by inductor, resistor and capacitor circuit, and then it enters the mixer. The output from the mixer is the difference between the phase of the two signals. The quadrature detector has the advantage that it can work with fairly low input levels of around 100 mV. We'll see you in the next one. Till then, bye.